So now we'll see how to find out the median and mode of the data given. So first we'll move on to the median. As we have already studied about the mean, how to find out the mean in case of the discrete frequency distribution or the continuous frequency distribution table, or let's say random data. But how to find out the median? First we understand what do you mean by median. Median is actually means the mid value of all the observations given. Let's say suppose if the observations are given as, let's say, 2, 6, 4, 9, 3, 1, 7. Let's say these observations are given, and if you need to find out the and if you need to find out what will be the median of this. So how to find out it? What you can do is, first basically what you need to do is you need to arrange this data either in the ascending order or in the descending order. So accordingly, first we'll arrange this data in the ascending order. Let's say 1, 2, 3, 4, then 6, 7, and then 9. So accordingly we have arranged this data in the ascending order. As now we have arranged this data in the ascending order, and now what we will do is we will see what will be the mid value of this data. So as you are seeing, there are 7 values: 1, 2, 3, 4, 6, 7, 9, and the mid value is the middlemost value that is equal to this mid value, which is equal to 4 in this case, because 4 is the middle value of all these 7 observations. As 4 is the middle value, so median of all this observation is equal to 4. So in this way we need to find out the median of the data given. So whenever this random data is given, accordingly we need to arrange the data in the ascending or descending order, and then accordingly we will find out the mid value of this. But in the previous examples, as you have seen, that the number of observations is odd. So number of observations are odd. That is, number of observations are 7 in this example. So when the number of observations are odd, so way to find out the median is n plus 1 by 2 term. So the n plus 1 by 2 term will be the median of the data. So accordingly, in the last example, n is equal to 7 because 7 observations are given. N is odd means n is the number of observations given, and as the number of observations are odd, that is equal to 7. So our median will be 7 plus 1 by 2. That is fourth observation. Yeah, fourth term will be our median. So as you see, the fourth term here is 4 after arranging it into the ascending order. So it is very necessary, before you need to find out the median, it is necessary to arrange it in the ascending or descending order. So after arranging it into the ascending or descending order, you can easily find out the median if the number of observations are odd. But if the number of observations are even, so way to find out the median is n by 2 term plus n by 2 plus 1 term, and accordingly we need to take the mean of these two terms. So that is n by 2 term and n by 2 plus 1 term, and we need to take the mean of these two terms. So that will give us the median. So like suppose if I take the observation as, let's say, 4, 3, 7, 1, 9, 8, 2, and let's say 6. So accordingly I have taken 6 observations. So first I need to do is I will have to arrange this into the ascending or descending order. So 1, 2, 3, 4, 6, 7, 8, and 9. So I have arranged this 8 observation in the ascending order, and now my median will be n by 2 observation. N by 2 means here n is equal to 8 because number of observations are 8. So n by 2, that is fourth observation, plus n by 2 plus 1, that is fifth observation, divided by 2, and that will give us the median. So fourth observation here is 4 and fifth observation is 6. So that is 4 plus 6 by 2, that is equal to 10 by 2, that is 5. So median in this case is equal to 5. So in this way, like, we need to find out the median. So if the number of observations are odd, then there will be only one middle term, and that will be our median. And if the number of observations are even, then there are two middle terms, and that will be our median. So this is the way to find out the median. In the same way, like if there is discrete frequencies table is given. So these were the example previously, like we have seen, is for the random data. But if the frequency distribution table is given, let's say first we'll take the discrete frequency distribution table. Discrete frequency distribution table. So if the discrete frequency distribution table is given, Then how to find out the median is, first we'll write down one example based on this. Then accordingly we'll see how to find out the discrete frequency distribution table. So first we'll see the example is, first we'll take the observations and frequencies, that is discrete frequency distribution table. So first we'll write down the frequency distribution table as 1 x will taken as 1 2 3 4 5 6 7 8 and 9, and accordingly frequency will take as 8 10 11 16 20 25 15 9 and 6. So accordingly I have taken the observations and the frequencies for that. So whenever this discrete frequency distribution table is given and we need to find out the median, then at the time we always have to find out the CF, and CF is actually the cumulative frequency. So we always need to find out the cumulative frequency whenever we need to find out the median of the discrete frequency data. So whenever there is discrete frequency data, always we need to find out the CF, that is cumulative frequency, in case of median only, but not in the case of mean or mode. So in case of median only we need to find out the CF, and way to find out the CF is, so first CF is 8, then next in the for the next observation what we need to do is we need to add this 8 to this next observation frequency, that is 10, so it will become 18, and next we need to add this frequency to this 18, so it will become 29. Then next we need to add this 16 to this 29, so it will become 45. And next we'll need to add this 20 to 45, it will become 65. In the same way accordingly we need to move, it will become 90, then 105, then 114, and then 120. So this will be our cumulative frequency. So this is the way to find out the cumulative frequency. It means we continuously need to add all the frequencies one by one to the cumulative frequency we are getting by adding the previous frequencies. So it means like suppose if this is the cumulative frequency of 3, so how we'll get this cumulative frequency of 3 is, this is the cumulative frequency of 3, and how we'll get this cumulative frequency of 3 is by adding all the frequencies of which are above 3 and up to 3, that is all the frequencies up to 3, that is 8 plus 10 plus 11. So that's why we got as 29. So this is the way to find out the cumulative frequency. So this is the way to find out the cumulative frequency. And now as you are seeing that n here is 120, that is number of observations are 120. And so as we have already seen, when the number of observations are odd or even, what we need to do. So here the number of observations are even, that is 120. So way to find out the median is actually n by 2 term, that is 60th term, plus n by 2 plus 1, that is 61st term, and accordingly we need to take the mean of these two terms. So if you see here on the basis of this cumulative frequency is actually helping us to find out which term exists where. Like if you see this one observation is given 8 times, so it means first we need to write this one 8 times, so this will become 8 observations, and then in the next observation 2 is given 10 times, frequency is 10, so it means we need to write 2 10 times. So this will become 10 observation for 2, and including the 8 observation for 1, it will become 18 observations up to 2. So in this way we actually need to write this data, because these observations are already in the ascending order, and these frequencies are given for the particular observations. So it means this data is already arranged in the ascending order, and and if you observe this cumulative frequency, we will easily know what will be our 60th and 61st observation. So if you see up to 45 observations, that is up to 45th observations exist here up to 4, that is up to 4 there are 45th observations, and after this 4 there are 20 more observations of 5. It means that we have added 20 to 45, so it becomes 65, that is up to 65 65th observation, up to 65th observation exist up to 5. So that is top 5 observations will make up to 65th observations. So up to 5 observation will make up to 65 observations. So as it make up to 65 observations, so definitely up to 45 observations exist up to 4, and above 45 and up to 65 observations, that is 20 observations exist for 5. So as 20 observations exist for 5, so definitely 60 and 61st first observation both exist here only, because up to 45th observation exist here and up to 65th observation exist here. So 60 and 61st observation will occur between this 45 and 65, that is our 60 and 61st both observations are equal to 5, because up to 45th observation the observations is 4 up to 45th, and from 45 to 65 there is observation that is 5. So from 45 to 65, that is 20 observations, here are 5, and these 20 observations uh, includes the observation 60th and 61st observation. It means our both 60 and 61st observations are 5. So it means we need to take this mean of this both these observation, that is 60 and 61st observation. So that is equal to 5 only. So it means 5 is our median. So this is the way to find out the median in case of discrete frequency distribution table. So accordingly, we need to see what will be the value of n, that is number of observations. Then accordingly, if the number of observations are even, then we'll need to find out the n by 2 plus n by 2 plus 1 observation, and we need to take the mean of those two observations. And if the number of observations are odd, then definitely there is only one middle observation, that is n plus 1 by 2, and that will be our median. So this is the way to find out the median. So as you see here, that 60, we need to find out the 60 and 61st observation, and both these observations are equal to 5, because up to 45 observation there is 4. First 4 observations, that is 1, 2, 3, 4 will consist up to 45 observations, and from 46 to 65, that is 20, next 20 observations are equal to 5. So that is, it means 60 and 61st both observations exist here in this part. 60 and 61st both observation exist in here in this part, that is equal to 5, and that's why our median is equal to 5. So this is the way to find out the median. But if the continuous frequency distribution table is given, that is continuous frequency distribution table is given, so what will be the method to find out the median? Is to find out the median, in that case there is a formula, that is L plus n by 2 minus Cf upon F into H. So this is the formula to find out the median in case of continuous frequency distribution table. So this formula is used only when there is a continuous frequency distribution table. Here L is the lower limit of median class, and what will be median class? Our median class, how to find out the median class is, our median class will be equal to where our n by 2 observations exist. So wherever there n is again the number of observations, so n by 2 observation exists in which class, we need to find out that, and accordingly that class will become our median class. And how to find out that, we'll see on the basis of one example. First we'll understand these terms. So our n by 2 accordingly we need to find out for finding out our median class. Now CF is actually the cumulative frequency of class preceding the median class. So that is, CF is actually the cumulative frequency of the class preceding the median class. So whatever class is there above the median class, so we need to take the cumulative frequency up to that class. Now F is actually the frequency of median class. So F is the frequency of median class, and H is actually the class size of median class. So H is our class size of our median class. So accordingly we need to first find out the median class, then only we'll be able to find out all these things, that is L, CF, F and H. So now we'll see one example, and accordingly we'll understand how to find out the median in case of continuous frequency distribution table. So first we'll write down the class intervals and frequency. Let's take class interval as 0 to 10, 10 to 30, 30 to 60, 60 to 80, and let's say 80 to 90. So this is our class interval we have taken, and accordingly frequency will take as 5, 15, 30, 8 and 2. So this our frequency we have taken. Now what we need to do is, most importantly, accordingly we first need to find out the cumulative frequencies and the n. So accordingly we'll first arrange this data in the proper tabular form, that is C or X or Ci, that is class intervals frequencies. We'll first write down this 10 to 0 to 10, 10 to 30, 30 to 60, 60 to 80 and then 80 to 90, and accordingly we'll take a frequencies at 5, 15, 30, 8 and 2. This is a frequency. Now accordingly first we'll write down the cumulative frequencies. So as we have already studied how to find out the cumulative frequencies, is first cumulative frequency is 5, as there is no frequency above this 5. Now for the next class intervals, the cumulative frequency is, we need to add this both frequencies, that is 15 plus 5, so it will become 20. Now we add this 20 to 30, so that will become the cumulative frequency of the next class, that is 50. And accordingly we need to add this 8 to 50, it will become 58, that is cumulative frequency of next class, and then accordingly 60. And if we add all this frequency, we also get 60. So it means our n by 2 is equal to 30. And if we see where this 30th observation occurs, n by 2 30 means our 30th observation. So if you see, up to 20 observation occurs in up to this class interval, that is 10 to 30, and from 21st to 50 observations it occurs between the class interval 30 to 60. It means our 30th observations occur here between 30 to 60. So that will be our median class. So this will be our median class, and accordingly we use the formula for finding out the median is, that is L. L is our lower limit of median class. Lower limit of median class is 30 and 60 is the upper limit. So we need to take the lower limit, that is 30 plus n by 2. N by 2, as you have already seen, is again 30 minus cumulative frequency of the class preceding the median class. So this is our median class, that is 30 to 60, and a class preceding this median class is 10 to 30, and cumulative frequency of this class is 20. So we need to take this cumulative frequency, that is class preceding the median class, divided by frequency, and the frequency is the frequency of the median class, and frequency of the median class is 30 into h, that is class size of median class, and class size is upper limit minus lower limit, that is of the median class, that is 60 minus 30 is equal to 30. So this will become our 30. So accordingly if we solve it, 30 plus this 30 and 30 will get cancelled, and 30 minus 20 will become 10, so it will become 40. So our median is equal to 40. So this is the way to find out the median of the continuous frequency distribution table.